So let's go ahead and get started then. We'll just stick with the statistics stuff for now. So when you're working with these statistics type problems, a lot of the times it's involving a graph of some sort. So this one's involving a box and whisker plot. The box and whisker plot below describes the weights of a sample of 100 chickens. So when you make a box and whisker plot, they collect a lot of data. If it's about the weights, they would have literally weighed 100 chickens, gotten every chicken's weight, and then they make this box and whisker plot from that information. So before we can even decide what statement, we need to know, well, what does this box and whisker plot mean?
What do it mean? I'm sorry.
Yeah. Yes, so we want to figure out what does the box and whisker plot mean. So we need to kind of pick it apart, and I'm going to tell you, well, this is what each piece means from the box and whisker plot. So the very first dot, that's the lowest piece of data. For the chickens, that would be the chicken that weighs the least. So the very first dot is about here. So the chicken that weighs the least would be 0.4 pounds, because they said LB for pounds. So then the top dot, if the lowest dot means the lowest value, the top dot means the highest value. That's going to be the heaviest chicken.
I swear this was on my test.
They probably did something similar, or maybe exactly the same. We don't know for sure. I don't have enough information about the tests, but hopefully it's similar at least to what you see. Okay, so lowest value, highest value. So for this graph specifically, you would go down and say, okay, that highest value, that's 2.4. The biggest chicken was 2.4 pounds. The line in the middle of the box, this is called the median. And it's basically the middle number. So not the middle as in the weight that's halfway between the lowest and highest. The middle number is, if you're actually collecting all this data, it's the middle weight of all 100 chickens. So, you know, maybe most of the chickens weighed higher than a certain amount. So the middle actual value of weights is 1.9. So there weren't very many chickens that weighed below 1.2 pounds. Since the box is mostly on the right. Oh, and this median has a second name. It can also be called Quartile 2. So they might call it Q2 for Quartile 2. But that's still just saying the middle value. Of all these numbers, this is the middle number. The left side of the box is the median of the median. It's called Quartile 1. And it's the middle value between the lowest and the median. So it's the actual number value of the weight that's halfway between the lowest and the median. And then one more, this is Quartile 3. And it's the middle, the median between Quartile 2 and the highest value. Ran out of room, so I'm going to write it to the side. So even just looking at the picture, there's a lot of information to get from the picture just looking at that. It's kind of a big, intense graph of data because so much of it means so many different things. So our statement options, which statement can be made about the data using the graph alone? So then it gives us some other information, and actually what I meant to say is some other definitions of words we might not know off the top of our head. The first word we need to know is range. Range has a very specific definition when we're talking about this kind of graph, and the range is always the highest minus the lowest. So they say the range of the weights is 3 pounds. We can figure it out by actually taking that highest value of the box and whisker plot and minusing the lowest value. So not of the number graph on the bottom. Yeah, the highest number on the number graph is a 3, but we want the highest number of the box and whisker plot.
So that'd be 2.4, right?
Yep. So 2.4
minus 0.4.
Mm-hmm. So I'm going to bring up a calculator. Or if you can do this in your head, you could actually do the subtraction in your head, but you can just type it in. 2.4 minus 0.4 is 2 or 2.0.
Yeah.
Same
That's
thing.
not right.
That is not right. So we can eliminate that answer. So then another definition, the median weight is less than 2 pounds. So the median was a very specific line on that box and whisker plot, which we labeled. It's the very middle line of the box.
1.9.
So 1.9, so is that less than 2 pounds?
Yes.
Yes. So the second one is our answer. Just to talk about the last two options, 25% of the chickens weigh less than 1 pound. So the quartile 1, quartile 2, quartile 3, it splits it into those data values. So quartile 1 is the first 25% of data. And it says, so from the lowest value to the quartile 1, that's 25% of the numbers. And the statement says that they weigh less than 1 pound, which is some of them, but part of that data is above 1 pound. So that's why it doesn't work, because this first 25% of data, some of it's above the 1 pound mark.
Oh, okay.
So then to quartile 2 takes up 50% of the data. So the first 50% goes from the very beginning until we hit quartile 2. So 50% of the data weighs more than 2 pounds. Well, the first 50%, that's below 2 pounds for sure. We go lowest value. I'm going to highlight a little bit better. We go lowest value to the median. That's all below 2 pounds. That's 1.9 or less. And then the top 50% of the numbers are from the quarter 2 to the highest value. So more of the data was grouped higher. 50% of the numbers fit in this tiny space between quarter 2 and the highest, versus 50% fit between the lowest and the middle. But it said weigh more than 2 pounds. There's just a little piece of it that's less than 2 pounds. So if it had been a bar in the middle right at 2, that statement could have worked, but since it was a little below 2, that statement doesn't work. Yeah, so each quartile gives you 25% more of the data. Okay. So any more questions about that before we go on? I guess there's a lot to these box and whisker plots.
Right. So I now I understand how to do it because I think that was one of the ones I skipped because I wasn't understanding it. But
Yep. Yep.
I'll just be needing refresher courses.
Yep. If they had said like 75% of the data, I'm going to get rid of a lot of this because it's getting really, really crowded. Sorry, it takes me a second to get rid of all of it, but okay, so that's probably good enough. 75% of the data, so from here to quartile 1, that's 25%. From the start to quartile 2, that's 50% because we had 25% more. And then from the start to quartile 3, that's 75% of the data because we had 25% more. So each new spot adds 25 more percent. Okay. So next one, a set of data contains 10 negative numbers and 4 positive numbers. Which one of these statements must be true? So 10 negatives, 4 positive numbers. We need to figure out stuff about the mean, median, mode, or range. So mean, they're saying the mean is going to be negative. Well, when we say mean, what does that actually tell us to do mathematically? Add the numbers together and divide by however many there were.
Right.
So there's a lot more negative numbers, but what if all the negative numbers were really small? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if all the negative numbers were really small and all the positive numbers were really big, if we add all these together, it's still going to come out positive.
Right.
So no matter what we do, this would come out positive and not negative. And if you can find even one case, if you can find one set of numbers where you're like, oh, that's going to come out positive, not negative, this statement's not true. It might be true some of the time, but it has to be true all the time.
Right, they gotta show the numbers, first of all.
Yep. Well, that's why they wrote it so generically. They want you to think a little more deeply about it.
Right.
Because they didn't show you the numbers. So that's why I write numbers in. I literally pick. I say, okay, I'm going to pick 10 negative numbers. I'm going to pick 4 positive numbers. What's that going to look like? Is there any way I could pick these numbers to make this statement not true? So the next one, the median is a negative number. So what did median mean?
The middle.
The middle. So if we go start to finish, and I'm going to move these, oops. Come on. Let me see if I can move these so they're all one long line. So if it's all one long line, the middle number, and I always go start to finish. I say, okay, I'm going to cross out the first number. Sorry, I didn't mean to turn that red. I was trying to just select red. Okay, if I'm trying to get to the middle, the first number would cross out with the last number. And the second would cross out second to last. And I just go along and I literally cross out going through the whole list. And when you do that, now you get to the middle. I guess one thing I did not do is I did not put the numbers in order. So You got to think of these little details because it's easy to make mistakes. It's the middle when they're in order. I'm going to fix that. So I've got to do that whole process again because I don't want just the middle of my random list. I've got to put these in order. -3, 1, 2, 3 -2s. And 1, 2, 3, 4, 5, 6 -1s. 3, 4, 5, 6. 200, 250, 310, and 400. Okay, now we can find the median. So watch out for those details. That's usually what kills a problem for a person. And if I hadn't been paying attention, I would have done that for myself. I would have been like, oh, middle number, we're good. But we've got to make sure they're in order. And then we cross out to find the middle. But when we cross it out to find the middle, let's see, we end up with 2. If there's 2 in the middle, you find the average, you take the mean, which still gives us a negative number, a -1. So is that going to be true all the time? Is there any other way I could pick these numbers if I fulfill these restrictions? 10 negative, 4 positive. That's all I can pick. Is there any way I could pick them so the middle number is not negative?
No.
No. No way I could pick them so it's not negative, so B is our correct answer. That has to be negative no matter what I do.
Mm-hmm.
Okay. Mode is a negative number. Mode means the number that appears most often, just to go through all the definitions. Range is the highest minus the lowest. It's the same as that box and whisker plot. So mode right now is -1 because of the way I chose my numbers. But if I chose all different negative numbers and all the same positive, then my mode would be positive instead of negative. So that's how mode could be positive. And then range is actually always going to be positive. If you do positive number minus a negative number, you always actually end up with a positive. If you have, the numbers we have are 250 minus negative, oh, sorry, 250 was not the highest. I need to look at my lowest list. 400 is the highest. This lower list has it on the far right. -3 is the lowest. When we have the negative, that's really 400 plus 3, which I'm going to have to write above because I ran out of room. And a positive plus a positive, still positive. So C and D also don't work because they could be positive. We can find one example where they're positive instead of negative. They don't work. Okay. So next one is still to do with statistics. The first one was they've already collected data and they made this box and whisker plot to interpret it. The second one was we're interpreting the data ourselves. This one is if you're collecting the data, what's the best way to do that? So George wants to conduct a survey. He wants to collect information to determine the types of music that the students want at a school dance. So there's some actual super important keywords here. What he wants to know is the music the students want. Knowing who you're actually trying to find information about is super important. This is called the population, but really it's just the people you want to know information about. Which sample population should George survey to represent the entire student body? So we want to represent all the students. Now it's super important to identify this because then it makes it easy to say, well, these people don't have any relevance to this population, or this isn't all the people I wanted to know about. So like answer choice A, that's a good one of these people have no information relevant to what we're trying to find about. If we survey the teachers, that doesn't address what music the students want. So they're just not what we want to know about, not the population. So we don't want to survey them. They don't give us good information. So what about B? Survey the captain from each sports team. Is that a good group to survey so that we represent everyone in the student population?
No.
No. Because it's only a small little group. It's not everyone. So that's not everyone we want to know about. Randomly survey 2 people from each homeroom class.
I think it's C.
You're right. That one gets all of the people in the school. Usually you can tell when something works if they're too specific and it's not, again, specifically. If they said, this dance is only for freshmen, then D might be a good answer. But they said the entire student body, so having it specifically just for the freshmen, not a good idea. So these questions look a little weird and a little complicated, but you really just want to focus on who do they want to know about and which survey actually tells me information about the group we want to know about.
All right.
Okay, so the next one, the table shows the number of people who speak each of the 6 most common languages in the world. So number of people in millions. Mandarin, which is Chinese, is 900 million. English is 430, Hindi 320, Spanish 310, Russian 280, and Arabic 185. Which type of graph is appropriate to display the data in the table? We can choose from bar graph, box and whisker plot, line graph, and scatter plot. So just off the top of your head, which one sounds the most useful?
Bar graph.
Good. So bar graphs are usually when you want to compare types of things. We want to see, oh, Mandarin has a lot more than English, and English is kind of close to Hindi, and Hindi's really close to Spanish. So if you're comparing different groups, that's a good idea. Box and whisker plot is usually when you have a lot of data. So you have so much data that you want to figure out, well, where's the middle of this data? Where's 25% of this data? So box and whisker plot works best for a lot of data. Line graph works best over time. A common one is like measuring your height from when you're a baby. You can plot over time, well, this is what's happening. And scatter plot is also one when you want to compare, but you're comparing more data than this. So box and whisker plot is more if you want to analyze a lot of data. Scatter plot is when you want to compare.
Yeah, I don't know about that one. The last one.
So a scatter plot is a good question. A scatter plot is when you make a graph. So instead of saying specifically, like if you recorded just my height over time, if instead you had a classroom with 50 students and you looked at all the heights of the boys. Compared to their shoe size. To have something to compare it to. It would end up with a bunch of data, like if you had someone that had a shoe size of 12, he's probably pretty tall. Let's go 6 foot 6 inches. He's probably pretty tall, and you could put his information here. So you'd collect all that information and graph it on the chart. You'd say, you know, maybe someone who has a, nope, that's 11, 10, 9, 8. Maybe someone who had a size 8 shoe was, oops, 5'0". He was like 5'2". He's kind of short. But then you might have some people that are called outliers. You might have a size 8 shoe, but he's 6'6". He's a really tall guy, but with short feet for some reason. Mm. But for the most part, you can expect the bigger your shoe size is, the taller you're going to be. So you're comparing all those people and saying, oh, I can make this comparison. The bigger you are, or bigger your shoe size, means taller.
So if it was a question like, I got all this data, which like this one, it'd be, you know, like comparison or something, you would use scatter plot.
Yep.
Okay.
Or they might give you a scatter plot and say, look at this scatter plot. What can you expect? What can you kind of, sorry, the word is failing me right now, but what can you determine from this data? So you could determine bigger shoe size means taller. Or they could say, does it have a positive trend or a negative trend? So if most of the data is grouped together like this, and you could draw a line through the center, even though there's one outlier, there's one that doesn't really fit most of the datas together. If you're going up and to the right, this is a positive trend. I'm gonna go to a blank page because I ran out of room. And there's negative trends. Maybe you have a bunch of data where you're actually going down. You have a bunch of dots, and for the most part, it's grouped together. You're going down and to the right. You could put a line in the middle. This would be a negative trend. Or they might say the word negative correlation. Or there might just be no comparison whatsoever. You might have collected data and it's just all over the charts. Sorry, these dots shouldn't be little lines, but I'm trying to create the graphs quickly. They should all just be little dots. So this data, nothing's grouped together at all. Nothing's close to each other. There's no line that you could kind of put in the center. So this is no correlation or no trend. We don't have any additional information from the graph itself. So scatter plots, there could be a couple of types of questions about it, depending on what they're looking for. Okay. Okay, so here we are. So next one, Aaron wants the mean. So we already talked about mean being adding all the numbers together, divide by how many there are. The mean of his 5 geometry test scores to be at least 90%. So we want the mean to be 90. His scores on the first tests are 85. So test 1 was 85. I'm going to just say T for test. Test 2 is 83. Test 3 is 96. And test 4 is 91. What is the minimum score Aaron can earn on the 5th test to meet his goal? So test 5, we don't know what it is. That's what we're actually looking for. Minimum score on the 5th test. But we do know that once we find the mean, we want the mean to be 90. So this is one where we don't just add them together and divide by 5 because we don't have the 5th test. But we do have answer choices that are possible test answers. If test 5 was an 89% and we find the mean, is it going to equal 90? So this is one where it's best to try each answer choice. We're going to check out answer choice A right now, and then we'll try B and C and D. So what do we get if we add all 5 tests together to help us find our mean? What do we get if we add them all together?
Five.
After we add it all together, we're going to divide by 5.
I got 91. 91%.
I got a little bit smaller.
Oh.
Sometimes when you're doing it by hand, it's easy to make a little mistake. And let me also double check that I typed it in right. So we have 85, 83, 96, 91, 89. Okay, so I did type it in correctly. You should have gotten 444 when you add it all together. And when you divide by 5, you get 88.8.
Yeah, I went off. I was off by a number. That's why I messed up by one number.
Yeah, adding it by hand, just it's easier to make mistakes. I definitely recommend typing it into a calculator. I'm still not 100% sure that this is the calculator online, the Desmos calculator, but there should be a button that you can click to open up a calculator and just type in and try it out that way. So 89 didn't quite work because we got 444 divided by 5 and got the 88.8. We did not get the 90 that we wanted. So that doesn't work. So then we're going to try the next number. Instead of 89, let's use 90. We're trying answer choice B to see if it works. So if we go to the calculator, we can actually erase the 89 on this calculator and just get the next one. So almost exactly the same. 445 divided by 5 gives us exactly 89 instead of the 88.8. So still a little bit off. So which answer choice should we try next?
100%.
100%. We're going to skip C and go down to D. Okay, so instead of 90, we'll try 100. So the first 4 don't change, but the last one is 100. Gives us 455. And that gives us 91%.
What is it? 91%?
Say that one more time. Sorry.
So it was right.
Well, did we want a
No.
91%? What did he want? At least 90%.
Right.
So if he got 100%, he'd be fine. It's where he wants to be. But he wants to know what's the lowest score I have to get.
Oh, the lowest. Okay. 95.
Yep. Mm-hmm. The 95 should change it to exactly a 90%. We put 95 at the end here. We get 450, which gives us exactly 90. So he can get 95 or above. So that is a small distinction, and I'm glad we saw that, because even though 100% is in the range he wants to know the entire range. He wants to know what's the lowest I can get, and then every number above that also works. So he has to get at least a 95%. So this one's not quite a statistics problem. I just wanted to make sure and include one of these free response problems where you have a lot to write down. So Cameron had 500 in savings on January 1st. Quinn had 800 in savings on January 1st. Cameron deposits $20 per week into a savings account, and Quinn withdraws. So deposits and withdrawals are kind of key words. What does deposit mean when you're banking?
You putting the money in.
Putting money in. We're adding money. And what does withdraw mean?
Taking it out.
Taking it out. Taking it away. So some vocabulary, again, you need to know to do a question like this. In your answer document, write 2 equations, one for the amount of money in Cameron's savings X weeks after January 1st, and one for the amount of money in Quinn's savings X weeks after January 1st. Determine the number of weeks until Cameron will have more money in his savings account than Quinn. Show your work or provide an explanation for your answer. So, first thing, write 2 equations. We have Cameron's equation and Quinn's equation. So when you write it out, I'd label it. I would literally just state, this is about to be Cameron's equation. So for Cameron's equations, how much money did Cameron start with?
500.
500. And then was he the one depositing or withdrawing?
He deposited.
He deposited $20 specifically. And how often did he deposit that $20?
Per week.
Per week. So deposit, we said, was adding. We said specifically it's 20. And then per week means you're doing it over and over and over again. And that's where we actually get the variable. The per week, they said specifically X weeks. So the per week means we put the letter X next to the 20. So this should count for full credit. You could also say Y equals to say the Y would be the amount of money, but they didn't specify you had to put the letter Y, so it should be fine without it. So Quinn's equation And you could even just label Cameron Quinn. You probably don't have to write the word equation, but you should label, you know, this is for Cameron, this is for Quinn. So Quinn's equation, we're going to do the same thing. How much does he start with?
He started off with $800.
Mm-hmm. And then is he putting money in or is he taking money out?
He's taking $15 out per week.
15 out per week. So we use a minus this time. So as you go, you can say, okay, I've answered all the questions for this paragraph. I wrote Cameron's equation. I wrote Quinn's equation. So then we're not quite done. That's not going to be all the points because it says determine the number of weeks until Cameron will have more money in his savings. So Cameron has more than Quinn. Share your work or provide an explanation for your answer. So there is a way to do this by setting the equations equal to each other and solving. But that, I think, is harder than just literally writing out a table. You know, on January 1st, Cameron had, let's put Cam for Cameron, he had 500, and Quinn had 800. And then a week later, I'm going to put 1W for 1 week. We know Cameron had $20 more and Quinn had $15 left. So how much money is after 1 week for Cameron?
520.
20. And how much for Quinn after 1 week?
775.
785.
85. Mm-hmm.
I split it up and I say, okay, 800 minus 10, that's 890. Minus 5 more, that's 885. Or sorry, 785. I said 890 instead of 790. And I can't write and talk at the same time, not 780, 785. Okay. So I would just do a whole bunch at once and I would write all this out. You're not going to get full points unless you show all of this. I would say, okay, Cam gets $20 every week. I'm going to just keep adding $20 for a bit. Quinn subtracts $15 every week. I'm going to subtract $15. Let's see, 60, 55, 40, 30, 25, 10. So we're getting closer, but not quite yet. We want to know the moment Cam has more than Quinn.
Oh, okay, I get it now.
Yep. So we just have to keep going, but we still have to show all this work since it's a free response. And again, I'm not quite sure how they're going to have you write it out since I think all the tests are on the computer now. But they should have a way for you to write all this information out. Or they've adjusted it so you don't have to have, maybe they would only ask the first question instead of the second. So I did a couple more weeks. Now I'm going to try Quinn. Let's see, 710 minus 10 is 700, minus 5 more is 695. 695 minus 15 is 680. 680 minus 15 is 665. So here's that moment. This is the very first week that that Cameron has more money than Quinn.
Week 9.
Week 9, yep. And I would write that as a sentence. You can circle it, but I would also say, Cameron has more money than Quinn on week 9. If they didn't allow a way for you to write this table, if you wrote this table as on a scratch piece of paper, you could explain what you did. I made a table showing how much money Cam had each week and how much money Quinn had each week. And I looked for when Cam had more money than Quinn. So normally you wouldn't need to write that much. But again, I'm unsure how they're going to do it since I think all these tests are on a computer now. So you might not actually be able to write in a table. So just to kind of cover all the bases. Okay. So this is a line graph. We're going over time. Oops. They didn't connect the dots with lines, but it's still a line graph. So the graph shows the population of Ohio from 1900 to 1990. Based on the data, in which decade did the population of Ohio increase the most? So first one is 1910 to 1920. Second is 1940 to 1950. Oops, that's the wrong line. Let me fix that. 1950 to 1960. And 1960 to 1970. So once you have the lines drawn in for each decade, so I just looked at, 1910 was this dot, 1920 was this dot. What happens when you connect them with a line? And 1940 was here, 1950 was here. What happens when you connect them with a line?
It goes up.
Yeah, it goes up. So it says which one increases the most, which one's increasing more quickly than all the rest, which one's steeper?
Mm. Is it 19? Is it D?
1960 to 1970. So 60 to 70 corresponds to this.
So, okay, I'm looking at it between 1980, 1950.
Yep.
To 1960.
Since the dots are so far away from the numbers, it's kind of hard to tell which dot goes with what. So you've got to be really careful because this line is clearly the steepest line. And I think you saw that was the steepest line, but when you went down to the numbers, it was hard to tell which dots were connected to which numbers.
Okay.
This one's another survey question. This time it's one of those free response ones again. A town is conducting a survey to determine if the residents would use a new recreation facility. So again, anytime it's surveys, look at who they're asking about. They're saying the residents of whatever town that is. The survey must represent all different types of people who live within the town. 3 different survey locations were proposed: a golf course, a daycare center, and a shopping mall. Every 5th person at the location would be asked to take part in the survey. In your answer document, determine which of the 3 proposed survey locations would provide the least amount of bias. Show your work or provide an explanation for your answer. So which place, the golf course, daycare center, or shopping mall, which one would have more types of people from the town?
Shopping mall.
Good. The golf course is a bad idea because only rich people golf. It costs a lot of money to golf.
Right.
So I would give some sort of an explanation like that. The golf course doesn't work or is a bad idea because only rich people can golf because it's expensive. Or something similar. So it doesn't represent everyone. What about the daycare center? Why does the daycare center not work?
Because everybody's kids will not go to daycare.
Yep. Doesn't work because not everyone's kids go to daycare. I don't think they're really caring how grammatically correct you are. Like my sentences aren't put together very well, but as long as you give the correct reason. You could have also said, and not everyone has kids. The shopping mall has the most types of people going to it.
You make this seem so easy. If only if I would have did this tutoring first,
Yep.
I would have passed.
Well, hopefully you'll pass this time, and hopefully what I'm teaching you is relevant to the test. Like I said, it's been hard to find information, so hopefully these are the types of questions you're gonna see, and now that you know a little bit more about them. So these survey questions look weird and look like they're hard, but really it's all about what group am I looking for? Did I actually find a survey that gives me that group? Okay. So I think this will probably be our last question. We're almost out of time. Sheila collects the following statistics about baseball games played by the local youth league teams. She gives the years, how many times they win, number of spectators, soda sold, and hot dogs sold. What statistic shows a non-linear rate of increase over time? So again, this one comes down to vocabulary. What does non-linear mean?
Not in order.
Not in order. That's possible. That is one version of non-linear. Linear itself means you're going up or going down by the same amount every time. So there's actually quite a few different versions of non-linear, up or down by the same amount. So what you said is one version of nonlinear, but we need to make sure we know all the versions of nonlinear every time.
It won't be the average number of spectators.
Let's see, spectators, yep, you're right. It would not be because you go up by 60, go up by 60 again, go up by 60 again. You're going up by the same amount every time. And you probably already thought about the number of wins and said, oh, I'm just going up by 2 every time.
Right.
How about number of sodas sold?
No, because they went up by 20, right?
20 the first time. What about the second time? Do they go up by 20 again?
No.
Nope. How much do they go up by the second time?
Like 40?
40. Good. How about the 110 to 180? How much are we going up the third time?
70.
70. So this one is nonlinear because it's not going up by the same amount. It went up by 20, then up by 40, then up by 70. It's got to be the same amount every time. It could have also gone like back down if they said, well, when there's 280 spectators, there's only 70 sodas sold. Adding 40 and then subtracting 40, that's still not linear because you went up one time and down the second time. So non-linear is very vague because there's so many non-linear things. You just have to check and say, well, if this is linear, that's not our answer. If it's anything else other than linear, it's nonlinear. That took a little less time than I thought. Oh, I thought I had a 10th question. Maybe I don't. Never mind. I guess that will be our last question. That was the last one I had prepared. So testing-wise, we still only have a couple more weeks before all the different places will be done with their testing. Once the last set of, because every county is doing a different testing date, once that testing date is over, we'll stop classes for a little bit until we get closer to the next testing time.
I'll go November 17th.
Okay, yep, so I will be going till mid-November, maybe a little later. I need to find out what the exact day is of the last test for anyone. And next week, I think it'll be about the same time. I'll send out a text message once I know for sure.
Okay. All right.
Thank you very much for coming, and I'll talk to you next week.
All right, thanks. Bye-bye.
Bye.